Welcome. This is your teacher David Garcia, and today we will be working with the topic of the circle. Now, to understand the properties of the circle, let's do a little graphical analysis. So what we have in here is a Cartesian plane. And let's imagine that we have 2 points on this plane. This point right here and another point right here. If I want to know the distance between these 2 points, I need some references. Now, what I normally do, or what we normally do, is that we trace the horizontal distance between these two. We measure it, we calculate it, and then we do the same for the vertical distance between these 2 points. And we do this because by doing this, we form a right triangle. Therefore, this distance between them, the black line, can be calculated by the Pythagorean theorem. Now, if we call this point, the one that we have down here, h, k, or the center of the circle, and this point right here, x, y, or for that matter, any point on the circumference, you will see that what we end up with is a circle. So that means that the equation that will describe any circle will have its foundations on the Pythagorean theorem. So let's see how that happens. Let's go back here and let's see. The Pythagorean theorem states that in a right triangle, if you squared one of the sides and you add it to the other side squared as well, you will end up with the hypotenuse squared. Now, we know that the horizontal distance is a change on the horizontal coordinates. The vertical distance can be calculated by a change on the vertical coordinates. And this will be equal to the hypotenuse squared. So in this case, the coordinates that we have for the horizontal are x and h. The coordinates that we have for the vertical are y and k. The distance between them is actually the radius, as you could see in the graph. So what we have in here is known as the standard equation of the circle. And our objective will be to be working with this equation. How so? Let's imagine that we are given conic equation. And the conic looks like this. X squared plus y squared plus 10x minus 28y plus 210, and this equals 0. We can identify this general conic equation as a circle. So our objective will be to rewrite this equation into the standard form. So that means that we will have to gather the terms for the horizontal coordinates and the terms for the vertical coordinates. This one right here, we're just going to isolate it onto the other side of the equation. So we will have x squared plus 10x. I am going to leave a little space in there. Plus y squared minus 28y. Again, I'm going to leave a little space, and this will be equal to negative 210. I'm leaving this little space in here to complete our trinome. Now, we have done this before. The procedure is identical. I'm going to take the number 10, divided by 2, and then I'm going to square it. And this will give me this number right here, which will be 25. Now, as I am working on an equality, whatever I do on one side, in this case, I am adding 25, I have to do it on the other side. So I am going to add 25. Now I'm going to repeat the process for the vertical coordinates. So negative 28 divided by 2 and squared. In this case, negative 28 divided by 2 is 14, and 14 squared is 196. What I do on one side, I do it on the other. And now I have this perfect squared trinome that I can rewrite by factoring it into a binomial squared. And I will do the same for this one right here. I'll just rewrite it in this way. By putting these numbers in the calculator, I will end up with my radius squared. So I will have x plus 5 squared plus y minus 14 squared. This will equal 11. So if you see, I have exactly the same format. And I have changed the standard form of the equation from the, general conic form of the equation into the standard form of the equation of the circle. That's it. Thank you very much, and I will see you in our next video.